Okay, we got ourselves an application. Please pause the video and read everything. While you are reading, think about what you don't know because that becomes your variables. All right, I hope you paused it. I hope you read that. So notice it says that we need to determine how many servings of the shakes in the packs he should consume, and we're going to try to minimize his caloric intake. And then also, how many calories will he take in? First off, since we don't know how many snacks he should consume of each type, then X should be the number of, let's see, are these servings? Yep, servings of, we'll call it protein pure. And then Y will be the number of servings of all energy. Okay. So now we're trying to minimize his caloric intake. So we'll say minimize Z equals to how many calories does each pure protein give him? It gives him 123 calories. So we'll say 123 X plus how many calories does each all energy give him? Gives him 115 calories. And we have Y of those. All right. Subject to, let me get rid of these guys here. Gone. Actually, I can get rid of the highlight too. We don't need that anymore. All right. And now think about, what do we have restrictions on? Well, we have restriction on protein, carbs, and fat. So each one of these are going to become a functional constraint. So let's put all the protein numbers together. The shake has 24 grams of protein, and we have X shakes. And packs have 12 grams of protein, and we have Y packs. And he needs at least, which means greater than or equal to, 72 grams of protein. All right. The pure protein shake has 0 grams of carbs, and we have X of those. And the energy pack has 10 grams of carbs, and he needs at least 10 grams of carbs. All right. And then the pure protein shake has 3 grams of fat, while the energy pack has also 3 grams of fat, and he needs at least 12 grams of fat. And he can't have a negative number of either thing, so we can say X and Y are greater than or equal to 0. By the way, that's my dog walking around. I think he wants to go potty. I was right, he wanted to go potty. All right, so we have made our linear programming problem, which now means we need to graph it and find all of the corner points. So just like we did in previous videos, we'll take the inequality 24x plus 12y greater than or equal to 72, and we'll graph that. Boop. Let's see, I need a line here. Okay, so that would make the x-intercept 3 and the y-intercept 6. 1, 2, 3, 4, 5, 6. So something like that. Then I have to doing things. That looks good there. Now, because I'm on a tablet here and it takes a while to shade, I'm only going to shade the very end. But at this point, you should already know that after you draw the line and label the line, you should do your shading. But just to save time for me, I am just going to shade at the very end. Because, you know, things. So the next one would be y equals 1. Well, and that comes from 10y equals 10. Oh, wrong color. Oh, don't tell anyone. Okay. And then the next one will have x and y intercepts at 4. If none of this makes sense, what I'm doing, go back and watch previous videos where we talk about finding the feasible region. Okay. We are cooking. Okay. So your feasible region will be all this up here. And again, that technically does come from shading each region and finding where they overlap. Because I am in possession of an amazing beard, I already know where this answer will be. So that's why I'm just doing the final answer. But you should get this as your feasible region. And I'm a little scared about coloring too close to the line, so I'll just let go. Okay, so notice that we have 1, 2, 3 corner points. We have this ordered pair right here. We have where the blue and the green intersect, and we have where the purple and the blue intersect. That's it. This is not a corner point. This is not a corner point. This is not a corner point because it has to touch or be part of the feasible region. Now this one, the y-intercept of the green line, we should already have based on our y-intercept of the green line, and that's at 0, 6. The other two that are sitting out there, namely these guys, this is where we would use the RREF command in the calculator to figure out what those lines are. So pull up your calculator. Boop, there's my calculator. Don't worry about that. I was doing it for other things. And then let's do the blue and the green. So we'll go to second matrix. We'll create a matrix. I'm going to just overwrite the one I have here. We'll do a 2 by 3 because we have 2 equations. I'm going to make sure that's on. Okay, good. We have 2 equations, the green and the blue. So there's 2 rows, and we need 3 columns, x, y, and constant. So it doesn't matter the order in which you put them in. So if I put the green in first and then the blue or vice versa, it's fine. Just make sure they're both in there. And just double check your work. So second matrix, edit, put your matrix in. Quit out of there, go back to second matrix, scroll over to math, and you're looking for RREF, and then select your matrix. I called mine A. So that ordered pair is 2, 2. Please do not use the graph to determine the ordered pair, because if your graph is wrong, there goes the whole thing. Mine did look close to 2, 2, so yay. And you can do the same thing for the other one. If you do, you get 3, 1. So again, rewind that part of the video or go back to a previous video to see how that was done. Okay, so now what we do to finish off this problem is we make a little chart. And we say X, Y, and then Z. And then you list only your corner points. So 0, 6 means you're going to put in 0 in for X and 6 in for Y. Let me pull up my calculator again. In a previous video, I showed how to do this using matrix multiplication. You don't have to. You can, let me take it the other way. You could do this manually like I'm doing right now. So 0 for X, 6 for Y. That gives me 690. Ugh, that was weird. And then I'm going to just hit second enter. And then I'm going to change 0, 6 to 2, 2. And that gets me 476. I gotta do that. 476. And then one more time. Instead of 2, 2, we'll have 3, 1. And we get 484. So remember, we are trying to minimize, so we would say that Peach should eat 2 pure protein shakes and 2 all energy packs, and the minimum caloric intake we discovered to be 476 calories.